Hello everyone, I start presenting a paper with title A Data-Driven Approach Based on Tensor Compilation for Replacing Physical Sensor with Virtual Sensor. My name is Noor Ali and co-authors of the paper are Hadi and Mahmoud. Sensors are being used in different industry for anomaly detection and health monitoring. uh, but sometimes the operation and maintenance of sensor are costly, so company or industrial partner that produce high speed separator wants to reduce the number of sensor from 5 to 2, as you can see in the picture. So but the simple solution for this is we just keep the most powerful pair of sensors and delete the others. With the discarding the others, we lost large amount of historical data that is informative. So we formulate the first problem to this: can we develop a data driven solution that enable us to remove sensor but keep their virtual replica physically? Virtual sensor technical solution for virtual sensor can be categorized to three categories. First is first principle, apply some fundamental physical law. The second is data driven, use empirical correlation without any knowledge of physical sensor. And hybrid is combination of first principle and data driven. Application based solution, categorized to three category. Backup is used for verifying the accuracy or calibration of physical sensor. Replacement aims at cost reduction and reliability consideration. And observing, estimating quantity that are not directly observable or measurable. So our proposed method fall into data driven and replacement. And our contribution is we propose first sensor compilation based method for creating virtual sensor, and we validate the effectiveness of proposed method with real data set of several high-speed separator. We have data from conditional monitoring signal from high-speed separator machine with 5 to 7 sensor. It contains 380,000 binary file from 109 machine. We exclude 14 machine from different generation. Data collected from 2013 to 2020, and we have three frequency range: 200, 2000, 5000. In data processing, pre-processing, we faced some issue. One is data have uh, each machine have different time instance from 1 to 1982 time instance. You can see the different time instance per machine here. And sensor reading are not aligned at the exact time, so we should fix this problem. So after that, the natural structure of the data will be a four-way tensor with the dimension of sensor number, control parameter, frequency, and time. Another issue in data was we had not uh, any road alarm company use a threshold-based alarm detection based on the normal operation of the machines. So finding the normal operation point was another challenge for us. We choose two approach. First approach is fixed percentage. We use 20, 10, 5, 4, 2, 1 percentage of data for finding the training period. But we see that we have alarm in the training period, so we choose another approach, adaptive approach. We start from the first time instance and until the end, and check the data with the alarm threshold and find the training period. We had two type of machines, one with the one period and another with two or three period. So we choose the last point of the first period as the end point of our training period. Method. The task is finding the most informative pair of sensor. Idea is reusing historical data of removed physical sensor along with current data of remain sensor and use tensor compilation to impute the data for removed sensor. Assumption is tensor compilation can effectively approximate the data of removed sensor. Tensor compilation. Estimating the value of unobserved element in a tensor based on the relationship between the known and unknown part. TTNN is a tensor compilation method. Technically, TTNN is similar to TSVD with difference that is more computationally efficient. This is the algorithm that we propose. We have input and output is base pair of sensor. Imputer is TTNN, and we list all possible combination, choosing two sensor out of 5 sensor, and for each combination we use this approach. We have a sensor, we keep data of 2 sensor, and for remaining sensor we use k-fold approach, and we set uh, in each fold that folds data to none, and after each fold we use tensor compilation, and we predicted the value with help of tensor compilation and compute the MAE, and we have one MAE for each fold, and we take average and mean, and we choose the uh, best pair of sensor after we complete for all combination. Experiment. We have a configuration for the experiment. We use TTN and with the package recommendation setting. For choosing best pair of sensor, we want to know which pair of sensor could provide the lowest estimation error, and we create critical diagram on MAE based on the Wilcoxon-Horn test. And for alarm detection, we choose 29 machine with no gap in their recording. This is the total time instance for this machine, and the tensor size will be 13, 5 by 3, and nn is the number of time instance. Now company use this rule. If measurement go beyond 5 standard deviation, it's raise alarm. We use this approach for alarm detection. For effectiveness of virtual sensor, we have 3 settings: keeping 1 physical, keeping 2 physical sensor, and keeping 1 physical plus 4 virtual sensor. For keeping 1 physical and 2 physical, we check the value of tensor with the alarm range and comparing the result with the alarm ground truth and reporting, precision recall, and F measure. For keeping 1 physical sensor plus 4 virtual tensor compilation based virtual sensor, we keep 1 sensor data, and for the 4 sensor we use k-fold approach. We set in each fold data to missing, and after that we use tensor compilation, and we do alarm detection and report precision recall and F measure for each fold, and we take average and mean, and after we complete the all combination, we report the best pair of sensor. And you can see the result of choosing best pair of sensor based on the average MAE. You can see the average rank of keeping 1 and 2 is the best, so keeping 1 and 2 is the best choice, and performance difference between different sensor pair are significant. We choose a significant level alpha to 5%, and this table are the result for our experiment. Table 1 is result for 1 physical sensor, keeping 1 physical sensor, and you can see improvement in the third decimal point, but sensor 2 is the best. And table 2 is keeping two physical sensor, and we have four configuration that has the best performance. But there are subtle difference between different combination of sensor. And table 3 is one physical plus four virtual sensor. We have four combination that have the best performance, but uh, there is not much difference between pair. And as you can see, this number is near, uh, I mean, one physical plus four virtual result is near to two physical sensor result. We use data uh, of keeping one physical and keeping one physical and four virtual result, and plot critical diagram. And as you can see, uh, all five scenario with virtual sensor outperform the scenario without virtual sensor significantly, and no significant difference between which physical sensor to keep. So the physical plus four virtual outperform the physical. Conclusion, we propose first method based on tensor compilation for replacing physical sensor with virtual. Only one sensor and four virtual sensor imputed by tensor compilation can produce an anomaly detection performance as accurately as two physical sensor, and any progress in the accuracy and performance of the tensor compilation algorithm can directly affect the quality of sensor. And this is the reference that I use in the presentation. Thank you very much.